Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 9 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 3583. Count special triplets. So in this problem, you are given an integer array nums, right? A special triplet is defined as a triplet of indices I, j, and k such that I is less than j and j is less than k, and k it should be less than n, and I it should be greater than equal to 0, right? Where n is equal to nums dot length and nums of I value is equal to nums of j into 2, and nums of k value is equal to nums of j into 2, right? So whatever nums j value we have, let's say 2, right? So my nums of I value is going to be this value into 2, right? And my nums of k is equal to this value and into 2, right? So that simply means that whatever this value we have, this value and this value, it should be double of this one, right? This is the meaning of this thing, right? We have to return the total number of special triplets in the array, right? Since the answer may be very large, we have to return it modulo 10 to the power 9 plus 7, right? Very easy problem statement, right? Clear? Okay, now see this example. So I see now, if I take this value and this value and this value, right? 3, and here both sides we have double value, right? 6 and here 6, right? So this is one valid, right? Clear? So let's pick the same example, right? So here 3, and in this side we see 1 6, right? Only 1 6, and in this side also we see only 1 6, right? So how many total valid pairs? 1, right? 1. Okay, now little bit twist here. Let's say here 2 6 are there, and 1 3 here, and 1 6 and 1 6 here. Okay, so now here in this side we have 2 6, right? In this side also we have 2 6, right? So in total how many we have? So let me show you how many we have in total. 6, then this 3, and then this 6. Okay, 6 3 6, 6 3, and then this 6 6 3 6, again this 6 3, and now this 6, right? So 6 3 6, now again this 6 this 3, and now this 6, right? 6 3 6, right? So here if you see, here let's say this value is nothing but c, and this is a, this is b, this is d and e, right? So here if you notice now what I'm doing, a, and I'm using this d, right? Here I'm using b and d, here I'm using a and e, here I'm using this b and e, right? Like this. So total 4, right? Total 4 are there, right? So simply means here 1 into 1 is nothing but 1, 2 into 2 is nothing but 4, right? This is what we need to do, right? Same way, I'm just clearing the doubts why we are doing multiplication here. Okay, nothing else. So here let's say 3 6, right? And here 3 6 again. So in this side we have 3, in this side we have 3, so in total we will have 9, okay, for this one. And what are those 9? So here a b c d e f g. It I'm just showing these values a b c just so that you guys get clear why what I'm doing, right? So it's just nothing but I'm just writing in alphabetical order, right? Okay, so here d is fixed, right? So I am making pairs of a and e here, then a and f, let's say a and g, right? Then b and e, then b and f, then b and g, then c and e, c and f, then c and g, right? So in total 1 2 3 4 5 6 7 8 9. Okay, so we have to do multiplication. All right, now see this example number 2, right? So here we have to choose three values, right? One is I, one is j, and one is k, right? So definitely I can't choose this value as my j, right? At nums of j I can't choose, right? Because I need I, and I should be less than j, j should be less than k, and k should be less than n, and I should be greater than equal to 0, right? So these are the conditions given to us, right? Clear? These are the conditions given to us, right? So here what I'm going to do now, okay? So here let's choose this triplet, 0 index, 1 index, 2 index, 3 index. So let's choose this, right? As your middle value, right? So 0 and in this side 2 into this 0, right? So here also we are getting 0, right? And here 2 into this 0, right? 2 into 0. So here see this, we have this one, right? This and this if we choose 0 2 3, right? Because nums of 0 is 0, nums of 2 is equal to 0, nums of 3 is equal to 0, and nums of 0 is equal to nums of 2 into 2, right? Good. Nums of 3 is equal to nums of 2 into 2. Good, right? So we have this one, right? So this is what we need to do, right? Here if you see the constants, and is nums dot length from 3 to 10 to the power 5, and nums of I values 0 to 10 to the power 5. Okay, so now here what approach should come to my mind now, right? So like for this 4, if I'm at this position, so definitely I'm going to search for 8, right? 8 in this side and 8 in this side, right? If I am here at this 2, so definitely I'm going to search for 4 in this side and 4 in this side, right? This is what should come to my mind, right? If I am at here at this particular position 8, so definitely I'm going to search for how many 16s are here and how many 16s are here, right? This is what I need to search, right? So from this thing, one thing comes to my mind right here, that if I know at which position this 4 is there, at which position this 2 is there, at which position this 8 is there, if I know this now, then it will be very easy for me, right? This thing comes to my mind, right? So if this thing comes to my mind, right, so what I'm checking the numbers, and I'm checking at which position they are occurring, right? 8 is occurring at 0 1 2 3 4, 0 and 3 index, right? Like 4 is occurring at 1 and 4 index, right? And 2 is occurring at 2 index. This thing comes to my mind, right? At which indexing these things are there, right? So if this thing comes to my mind, this is nothing but map, right? And this map is of nothing but these keys as integer and this values as nothing but list of integer, right? This thing comes to my mind, right? Okay, so let's say I created this map, right? Now once I create this map, I will also show you one more shortcut. Okay, this is nothing but approach 1. Once I complete this approach 1, then after that I will move to approach 2. Okay, so first let's see the first approach which comes to my mind first. Okay, so this comes to my mind right now. After that, what I did here, I need to iterate over all these values, right, one by one, right? But I don't want to start from here, because if I start from here, this can never be my middle value, right? I need to choose 3 values, right? So definitely I want to select my j as some middle value, right? So definitely my j is going to run from this to this position, okay, this to this index, right? This is clear, right? Okay, this is done. Now what I did here, this is my array 84284, right? So now if I'm here, right, at 4, okay, I'm at 4. Now if I'm at 4, then definitely I'm searching for what? I'm searching for 8. So first I'm directly going to check in my map if my map contains this key 8 or not. If it contains key, then there is a separate process we need to follow. If key itself is not there, then I can skip this index easily. I can easily skip this index. No need to count anything, right? Okay, but here 8 is there. Okay, now 8 is here. My j is here at index 1. Now next thing, in this 8, these are the different index I have, right? I have 0 and I have 3. Right now I am at 1, so definitely I need to find the number of indexes, the count of number of indexes in the left side, the count of number of indexes in the right side, and once I get the count, I have to just do the multiplication between them, right? So here we have just one count, here we have just one count, right? So 1 into 1, so total 1 possibility with this as j, right? That is nothing but 848. Clear? Okay, now next time when my j is here, so 2, I'm going to search for key as 4. 4 is there, so 1 and 4, so this is 2. So before 2 how many values are there, and after 2 how many values are there? 1 1, only 1, right? So 1 into 1 is 1, right? And you know why we are doing multiplication, right? So here I'm going to get 4 2 4, right? That's it. 8 for 8 I'm searching for 16. 16 is not there, key is not there, I can skip, right? So this is what I need to do. Okay, all right, you did this, very good. Okay, you are just iterating over of and here, and here also, if you are iterating over all the values, right? So let's suppose here, let's suppose your nums array, right, of length 10 to the power 5, right? uh okay, 10 to the power 5, and let's say all the values are same, right? Then in this list also we have of n values, right? So first you are checking for of all of n values, then again after that you are also checking again of n values, right? Okay, what I'm saying here, let's say you have two here, and all these four, okay, so many fours are there, right? Let's say you are here, definitely you are checking all these one by one, right? The middle values of n times. Now for two, list of index is very big here, 0 1 2 3 4 5 6, around 10 to the power 5 until here, right? So many indexes. So again in the list also, you want to iterate over of n time, then your time complexity is going to be of n square. This is going to give you the time limit exceed error, right? This should give you the time limit exceed error, right? So now here if you see, these values are already sorted, already sorted index we have, and I need to do searching on top of it, right? So what should come to my mind now? Binary search should come to my mind now, right? Binary search. So we always apply binary search on the sorted array, right? And it is faster, right? It is faster. Okay, so this is what I should do for my approach one. Okay, now how binary search is going to work, right? This you guys already know, right? So let's say my j is at 3, so I am finding all the values, right? Let's say I have 1 2 5 8 9. Okay, now if my j is 3, right, so I am searching for all the indexing which are less than 3 and which are greater than 3, right? And then I am multiplying. This is what I'm doing, right? So how your binary search is going to work, right? So what you do in binary search, right? So let's say I want to count the indices, count indices which is less than j, right? So you take your low as 0, right? Clear? And you take your high as uh, the you can take it as, let's say these are the values, but these are my indexing 0 1 2 3 4, right? These are indexing. Okay, so let's take low as 0 and high as your 4, right? Low as 0 and high as 4. Okay, now what you need to do here, okay, after that you have to run one while loop, right? While your low is less than equal to high, right? How you do this? While we have solved many problems related to binary search, right? You can check a playlist on my channel, right? Or you can check all the questions related to binary search on my GitHub, right? So I will add the link, right? I usually add the link, right, for all the problems, LeetCode problems, right? GitHub link, so you can check. There will be one separate folder for binary search. Okay, so this is what you need to do, right, in binary search. And then you calculate the mean, right? So you will get some mid, right? Mid some index you will get. Okay, so here right now in this case, uh, how you calculate the mid? You calculate the mid like this one: low plus high divided by 2, high divided by 2, right? Sometimes instead of this you used to write it like this: high minus low divided by 2. So if you do this now, this is also same thing, this is also same thing: low plus 2 low, right, plus high minus low divided by 2, that is nothing but low plus high divided by 2, right? Same thing, this thing, right? But why we write it like this? Because sometimes this high, if I write it directly like this, and low is bigger value and high is some bigger value, right, definitely we will get integer overflow type error. Okay, so we used to write it like this. All right, so this you already know, I know. Okay, so this is done, right? So okay, now this is done. Now what you need to do, you get the mid, right? And here 0 4, so let's say I get the mid as 2 0 2, I will get 2. Okay, so now add 2, I will check, right, this value, right, 5. Tell me if this 5 is nothing but these are the indexes of array, right, and these are the indexes of list, right? So 5 is less than this j, is less than this j. 3, no, right? 5 is not less than j. So then in that case what's going to happen, right? In that case, since our this value 5 is greater than equal to 3, right? So what I'm going to do, I'm going to update my high as mid minus 1, right? So high as mid minus 1. So high is going to be 2 minus 1. Okay, I am going to update it. So now in this side I have to check, right? In this side I have to check. I will do one thing. I will get new high as 1, right? And from previous case, I will store one IDX value, let's say mid, right? So in this case, whenever this is the case, right, whenever my I will say list.get this mid, right, from this list.get mid value, right, 2. So this value, if it is greater than equal to j, right, this case, right, in that case my high I am going to update it as mid minus 1, mid minus 1. Okay, when I'm going to write code, this will get more clear. Okay, and I'm will update this index. Okay, this is done, this is done here, right? Okay, this is the first thing, right? Now again, your low, this while loop, while low is less than equal to high. So now low value, previous low value is nothing but previous low value is nothing but 0 only, right? And high value is 1, right? So still valid, right? So now in this range we have to check, right? This is how binary search works, right? Now we have to check in this range. Okay, now in this range again you have to calculate the mid plus high or mid, right? So mid in this case is going to be 0, right? So mid is going to be 0. So at this mid 0, right? So if you see, we have one value, right? So tell me, 1 is greater than equal to 3. No, this time false. So in this case we have to just update our, in this case we have to just update our low as mid plus 1. Okay, mid plus 1. So now low is going to be 1, right? Low is going to be 1, new this time low is going to be 1. Okay, low is equal to mid plus 1, right? Mid plus 1. And again 1 is less than equal to high, high is 1. Okay, so 1 is less than equal to 1, again true, right? So again if you do this, so here we have 2, 2 is greater than equal to 3, again there is no update, right? Again your low is updated as mid plus 1. So now low is going to become 2, right? 2 is less than equal to 1, stop. So last time index is at 2. So this 2 means, simply means that we have two values which are smaller than 3, right? When I'm going to write the code, this thing will get much clear. Okay, so just keep this in mind, right? Same logic we have to write for the values count indices greater than j. So in that case, uh, what I'm going to do, I will do one thing, right? Count indices greater than j is 3. So I will get 3 output, right? In that case, definitely from this example. So 5 8 9, these are the indices greater than 3, right? So what I'm going to do, total size and the first index that I'm going to get. So total size is nothing but 5, right? And the first index in which we have greater value, right? So greater than value greater than this 3, right? So first index 5 minus 2 I will do here, right? So I will get 3. Okay, total 5 size and here 2, right? When I'm going to write the code now, this very simple binary search. Okay, so let's write the code, then I will show you one better approach, okay, in which we don't need to use the binary search. Okay, one pass solution will be there, right? Okay, so here int n is equal to nums dot length, and here final int mode is equal to 1 1 2 3 4 5 6 7 8 9, right? And then map value, right? So map here I'm going to store integer as a key, and here list of integer, right? And here map is equal to new hash map, right? New hash map, right? Okay. And here very simple, same thing for for here int I is equal to 0, I is less than n, and here I plus plus, and here after that we have to just put the values in the map, right? So what we need to do here simple thing, right? Map dot put, right? So first, for this particular key, if we have array list related to that or not, so here compute if absent, right? And here we have to write nums of I value, right? So I'm going to check if for this particular key we have array list available or not. So if array list is not available, then for this particular key I'm going to create one array list, right? Because we are storing the values in one array list, right? Okay, so here I have created one array list, right? Once I add it, then in this I'm just going to add the indexing, right? I values, right? And these I will always be sorted, right? Because I'm iterating step one by one, right? Here done. Then here you have to take one answer variable and set it to 0. Then after that I told you your j is going to start from 1, right? J is equal to 1, and here j should be less than n minus 1. Okay, j is going to run for the middle elements, right? And here j plus plus. Now inside this int current value is nothing but this nums of j, right? Nums of j, right? And your target is nothing but this nums of j and multiply it with 2, right? Now it's very easy. If your map, you have to check if the map contains this particular key or not, right? So if map dot contains key this target, right? So if it doesn't contain, right, I'm using negation symbol, right? So in that case I'm saying just continue, right? No need to check further. Otherwise you have to iterate over the list of that particular key, right? So list of integer and list is equal to map dot get the target, right? Done. Here this thing done. Then we have to count the left side, count left side, right? That is nothing but I is less than j, right? And same thing we have to again do for the count right side, right? So how I'm going to count the left count? Very easy. Int left count is equal to, I'm going to create one method count left, right? In this method I'm just going to pass this list that I have created here, right? And I'm going to pass a j value, right? So j is nothing but this, right? So for index, number of index which is greater than which is less than this j, and which are greater than j, this is what I need to find, right? So this is going to give me the left count, right? Very easy, right? As of now this problem is very easy, right? It will be easy actually, nothing complex here. That is why it is medium level, not hard level. Okay, and here we have to count the right side, so here let's say I do this right side, right count. Okay, count right, same thing I'm passing here, right? And I told you how I'm going to update the answer. We have to multiply, right? Answer is equal to, so I am getting the answer at every stage. And here for this particular j I have to just do the left count multiply with this right count, and this value can be very large, so I have to take care of this. So I'm just going to take mod, right? And in the end here I'm just going to return the answer, return answer. Okay, this is what I need to do, right? Here I'm taking answer in a long, but my return is int, right? So here just change it to int. All right, this is done. Now, very easy, right? Very easy. Now I have to just write this binary search logic, right? And this logic is same for count left, same for count right, nothing different, right? But there is one more approach in which we don't need this binary search itself. We don't need to store the indexing. I will show you. That is very interesting approach. Okay, so here let me just copy this. Count left side, right? So we have to count left side indices where I is less than j, right? So here private, I am returning the count, right? Int type count left, and inside this I will just pass the list of integer list, right? I can pass this, and I am passing the j value, right? So this j I am passing here, right? Now inside this same logic, you take one low as 0, you take high as the list dot size, total size of your list minus 1, right? So last index has the high, right? And let's say this idx is nothing but list dot size, right? Idx. So here what we need to do, we need to find the first index, right, which is greater than equal to, it is going to give me the first index which is greater than equal to j, right? This index value, right? Okay. And if I am going to get here this this 2, right? So 2 means this and this, right? So because this is 0 indexing, right? This is 0 based indexing, right? 0 1 2 3, right? So if this is the first index where we have value greater than equal to j, right? First value which is greater than equal to j, right? So in this place I have 2, right? So this 2 I don't need to modify anything, right? Because this 2 is nothing but it is representing the previous 2 values, right? Previous 2, there are 2 values. 3 means previous 3 values, if you see. 4 means previous 4 values, right? Because it is 0 based indexing, it is automatically taken care, right? Right. Okay. So here simple logic, while low is less than equal to high, right? And here you have to calculate the mid as low plus high minus low divided with 2, right? And now here if you check, if list dot get the value of mid, right, this value that you are searching, right, if this is greater than equal to j, right? So if this is the case, I told you, right, in that case just update your index as mid, right? This idx is going to search for the first index which is greater than equal to j. So right now I am updating my idx like this, right? But if this is true, right, then maybe in this side maybe I have some value which is greater than equal to this 3, right? Because this list is sorted, right? So if with the 5 is greater than equal to 3, then maybe in this side I will see 4 or I will see 3, right? So I have to move to the left side. So if I need to move to the left side, then initially my search is from here to here. With this answer is possible. Now I need to search in this side, right? So definitely this high is going to be moved to this, right here. This is how we write binary search, right? So here I'm just going to update my high as mid minus 1, right? And else means opposite of this. So in this case we have to move to the right side. So that simply means I'm going to update my low as mid plus 1, right? And from here I'm just going to simply return the idx. That's it, right? So this is what we need to do, right? Same thing you need to copy, same thing you need to paste for your other logic. Count right indices, right? Count right side indices, right side indices, right? I is greater than j, right? So here in the count left, right, here you have count right. Okay, so just update it to count right. Okay, and here same thing you have to do, but in this case list dot get mid is greater than j. Okay, strict. And here first index we are searching which is greater than j, right? Okay, and here whatever the idx value I'm going to get, right? So overall from list dot size I need to subtract, okay, minus idx, right? This is what I need to do, and I think that's it. Okay, so what I'm doing here, first value strictly greater than, right? So this is the first value which is strictly greater than. The overall size is 5, and here this, right? Because if I have something like this now, 1 2 3 5 8 9, so in this case strictly greater than 3 I'm searching, not this 3, right? I don't want to include this, right? So that's what. Okay, so this is what I need to do here, right? So overall, if you see here, 6 1 2 3 4 5 6 6 minus uh 0 1 2 3 4 5 6 minus 3 3, three values which are greater than this, right? But if I want to find smaller than this, then I need to search for this, because I will get a 2 here. 2 means previous 2, right? So this is how I write this code. Okay, so that's it. Now let's run it and see if the code will try to fix it. Okay, so yes, there are some issues. Let's fix that. Okay, so here j is missing. Let's run it again. Let's run it again. Again there is some issue. Which line? Here. Okay, let's run it again. Now again there is some issue. All right, here also. All right, now let's run it again. So that's it, right? So see, all the tasks have been accepted, right? Now let's submit it. So see, our solution is accepted, right? Very easy, very easy. But 58 lines of code, right? But this and this are similar, right? But logic is very easy that we are doing here in this approach, right? Very normal logic. Okay, now let me show you one interesting thing, how we can solve it without using this binary search, and total lines of code will be very small, not much. Okay, so in that case what I'm going to do, I will remove this. I will remove this part, I don't need it. I will remove this part, I don't need it, right? Okay, and here I don't need to do this as well, actually, right? So here also I can do one thing. I can simply reset. Okay, reset this, right? Okay, so in second approach, let's take the same example. 84284, 84284, remember, 84284, right? In this case what I'm going to do here, I will just count the frequency of all the elements. So 8 is occurring 2 times, 4 is occurring 2 times, 2 is occurring just one time. This is the overall frequency, right? Very easy. This is what I did, right? Now I am here. Okay, I am, let's say I am here. This is my value, right? If this is my value, then my target is 16 that I'm searching, right? Okay, now in the left side, tell me how many 16 are there. In the left side there is nothing, no 16, right? There is no 16 yet, right? So in left side there is nothing, right? And right now I have seen 1 8, right? I have seen 1 8 only as of now. That's it, right? That's it. Okay, and in the right side how many 16 we have? In the left side how many 16 as of now? We don't have any, right? So here this is nothing but I am doing the left count. Left count. Okay, left count, right? In the left count, named let's say my map, right? In that I just add the frequency of this 8 as of now, right? And here this map you can say total count map, total count named map. This is a left count named map, this is total count named map, right? So in the right side if you see, so from the total count, if are you seeing any 16? No, you are not seeing any 16. Okay, now answer, there is not no answer, right? In L side also 0 or R side also 0. Definitely we have to do L into R. No answer is there. Okay, now very interesting. Okay, very interesting, right? Next time your V is here. Okay, 4. Your target is your target is 8 this time. 4 into 2, 8. Okay. Now here in the left side you have already seen left count. You are here at this 4 and you in the left count named map you see there is 1 8, right, in the left side. This is 4 and this is its left side, so that's why I create one map named left count. In the left count I already see the frequency of 8 one time. Okay, so my L from left side count is 1. My R, how I'm going to count R? Total count of this 8, 2, minus left count of this 8, 1. I will get 1, right? So I am searching, total count is 8 overall, right? Now I am removing the left side, right? Definitely my 8 is not here. 8 will never be here at this position, right? Because I am searching for the double of this always. So double of this will always exist on this side or on this side. In this side I already know the count. Overall I already know the count. Then this side I can get the count using this formula. That's it. Very easy. Very interesting thing, right? Very interesting thing. Just we need to keep track of count. That's it. 1. Okay. Next time, this time in the left count again update the value of 4 to 1. Okay, you have already seen 4 one time. Okay, and your answer current value is 1, right? Because you see this 848, right? This 4, this 8, this 8. Okay, next time you move here 2. So for 2 your target is 4. So in the left side 1 4 is there. Overall 2 4s are there. So 2 minus 1 1. So 1 4 in right, 1 4 in left. Multiply it with 1, you will get one more answer, right? So answer update as 822, right? Then for 8 you are searching for 16. Again here to update frequency 1. Okay, now for 8 you are searching for 16. 16 is not there, 16 is not here, but 8 frequency just updated to 2. Okay, now again 4. So 4 you are searching for 4. Okay, now 4 is here. Now you are searching for 8. Okay, so 8. Okay, okay, left side 8 frequency is 2, but total left side, okay, you get 2, but right side overall 2 and left is 2, so again you're going to get 0. So correct answer, right? Very easy, very easy, nothing complex. Let's write the code. Very easy. Okay, so I can directly show you this approach and then video length will be smaller, but still I prefer to show you both approaches, right? Because you should know how first I come to that approach and then only I come to this approach after that, after doing some analysis of this. Okay, right? So here map of integer and total count named map. Okay, new hash map, right? So this is nothing but total count, right? Same way prefix count I have to calculate, so that is nothing but you can say left count, left count, right? Then you have to calculate the total frequencies. So here for int v in nums, right? So total count you have to calculate, right? So total count dot put, right, this key, right? Check if this key is there in your map or not. So get or default this key, right? If this key is not there, then take 0 in the starting, otherwise take that value of this particular key and add 1 to it, right? This is what you need to do. Okay, very simple. Now here create one variable long answer is equal to 0, and again just iterate over all the values in your nums one by one, right? And here what is your target? Your target is nothing but v into 2, right? This is your target. Then int l left count, right? How many target values appeared before this index, right? So how you get that? Left count dot get or default value okay, of this target. This is what you are searching, right? Otherwise 0, you are going to get 0 only, right? If there is no count. Now also I told you side by side that you have to update the value of the left count, right? This, so in the left count put this key, and if this key is not there, right, then uh, take the default value, right, of this key. Otherwise take the existing value and add one to it, right? Or we are just adding one, right? We are just updating the frequency, right, of this particular key, right? Same way I told you how you are going to get the R value. So R is very easy, right? So here total count dot, right, total count dot get dot default target comma 0 minus left count dot get or default target comma 0. That's it. And you are updating your answer as, that's it, very easy, right? Answer as answer answer plus, and here long L into R, and here mod. That's it. And here you have to just return the answer. Int answer. That's it. Now let's run it. Only 99 support, right? Only 99 support. So see, all the test cases has been accepted, right? Now let's submit it. So see, our solution is accepted, right? So in previous case, time complexity was off and log n because of the binary search that we are doing, right? But in this case, just off and time complexity, right? So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in the comment section. Till then, keep coding and keep practicing. Meet you guys next video. Thank you. Bye bye.